In this problem, you're supposed to turn a picture into one that is completely made up out of black and white pixels, such as the one that you see over here. And as you can see, the black pixels are distributed in this seemingly somewhat random pattern so that they look like grayish. And there is a well-known algorithm, the Floyd-Steinberg dithering algorithm, to do that. This Wikipedia article has the algorithm described pretty well. And like I said in the problem description, there's just a couple of issues. One is that for some reason, when they have the y that goes from top to bottom and the x that goes from left to right, that we would be writing pixel bracket y bracket x in that situation, because when you have a two-dimensional array, that's how the row and column indexes work. You have the rows going this way and the columns going this way. And so what one has to do is then just flip these in all situations. The other thing is over here where you see these multiplications here. That's not going to work with integer arithmetic, because 7 over 16, that's an integer over an integer, and that would just be 0 in integer arithmetic. Clearly not what we want. So you'd simply have to rewrite that as 7 times quant error over 16. And then that'll work even with integer arithmetic, because arithmetic goes left to right. So this one will get executed first, and that's going to be a somewhat larger quantity, and dividing by 17 is fine. The other thing is that here this was written without regards to bounds checks. So if you look at these four statements, each of them needs some guard to make sure that x plus 1 and x minus 1 and y plus 1 are within bounds. And that's really all one needs to do here. So it's not actually a lot of work. And the reason I assigned this was not because it was difficult, but because I thought it was pretty impressive that one could do this. So let's look at the source code here. Here you see 4 separate guard statements that make sure that the pixels are not going to fall off at the edge. You see over here the multiplication in this order, and you see here the y's to the left and the x's to the right, and that's really all that's to it. And then the pixels come out right. I do realize it's a bit of a pain if you didn't manage to divine exactly the way this is supposed to do, and then you had to do some amount of trial and error to get it right. And again, like I said, I didn't assign this because of its algorithmic complexity or because I wanted you to discover something, just because I thought it was a pretty nifty thing to be able to do. Alright, so I hope that you got that and that you enjoyed the patterns that come out of it.